Hello friends and welcome to your channel GATEquestionsECE, and I am back with next question on discrete random variables, and the question code is 105. So it's given: consider two independent discrete random variables x1 and x2 such that PMF of x1 and x2 are given below. So this is given the PMF of x1 and here it is given the PMF of x2. Then find the following probability that maximum among x1 and x2 is less than or equal to 1, and next is probability that minimum among x1 and x2 is greater than or equal to 1. So I request all the students to pause this video here for 2 minutes and try to solve this question on their own. So I hope students have tried the question on their own, and now I give you the solution of this question. So one of the possible way to find the solution to these kind of problem is you consider a new variable z, which is either equal to maximum. For problem A, it is equal to maximum of x1 and x2, and then you find the PMF of z. And to find the PMF of z, I have already made 4 videos in which I have discussed question number 102. I have made 4 videos: part 1 video, part 2, 3 and part 4. In this I have discussed in detail how to find the PMF of z, where z is equal to maximum or minimum function. And after finding the PMF of z for maximum or minimum function, you can easily find these probabilities, because in this case then this problem will reduce to problem A will reduce to probability that z is less than or equal to 1. So all after finding the PMF of z, all you have to do is sum up all the non-zero probabilities for which z is less than or equal to 1. And similarly for B, the problem will reduce to probability that z is greater than or equal to 1. So after finding the PMF of minimum function using the methods I have discussed in these 4 parts, you can easily find the probabilities here. And in the last of these 4 parts, I have given the shortcut method. So I will be using the shortcut method here to give you the solution of this problem in this video. So let's see how to use the shortcut method to find the probabilities that are asked in this question. So here I have copied the PMF of x1 and x2. So first step in the shortcut method is to write the joint PMF of x1 and x2. So we know x1 can take values -1, 0, 1 and 2. Corresponding probabilities 1 by 4, 1 by 2, 1 by 8 and 1 by 8. On this side we will write the probabilities and values of y. So y can take values -3, -1 and 2. The corresponding probabilities are 1 by 3, 2 by 9 and 4 by 9. Now we will write the joint PMF of x1 and x2. So jointly, to find the joint PMF of x1 and x2, we know the joint PMF of two independent random variables will be the product of the marginal PMFs. So we can write this probability will be equal to probability that x1 is x1 and x2 is small x2. So here it is x1 is equal to small x1 into probability x2 is small x2. So all we have to do is multiply these marginal PMFs. So 1 by 3 multiplied by 1 by 4 will be 1 by 12. So this is the probability, joint probability for, here it is x1, here it is x2. So this is the joint probability for x1 is equal to -1 and x2 is -3. So this point when x1 is -1 and x2 is -3, I have plotted in x1 x2 plane. So that point in x1 x2 plane is this point here in third quadrant. x1 is -1 and x2 is -3 for this point, and corresponding joint probability is 1 by 12. Similarly, we can find the joint probabilities for all these 12 points, and those probabilities I'm going to write here in this array. So this probability will become 1 by 3 into 1 by 2, so 6. This will be 1 by 24. This will be 1 by 20. So here it will be 2 by 36. Here it will be 2 by 18. Here it will be 2 by 72. And again 2 by 72. 1 by 9. 2 by 9. 1 by 18. 1 by 18. So these are the joint probabilities of x1 and x2, and these are the points that we can form from the Cartesian product of set of x1 and x2 values. So the next step for part A, we need probability that maximum x1 comma x2 is less than or equal to 1. So this is the probability of x1 and x2 lying in the region that is specified by this inequality. All we have to do is to identify the region that is defined by this inequality in x1 x2 plane, and then sum up the joint probabilities of all the points that are lying in this region. Now this inequality consists of two equations. First is where maximum x1 comma x2 is exactly equal to 1, and next is when maximum x1 comma x2 is strictly less than 1. So let's see what is the region in x1 x2 plane for which this condition is satisfied. So we know from a discussion of question number 102, in question number 102 part A video and part 2 video, I have made 2 videos on this. I will provide the links here in the I button and as well as in description. We know from discussion in this question that maximum x1 x2 is the region in x1 x2 plane which has shape of inverted L and corner lying on x1 is equal to x2 axis, where the corner is at point 1 comma 1. For example, if we wanted to know what is the region for maximum x1 comma x2 is equal to 3, say, then it is inverted L shaped boundary in x1 x2 plane with corner lying on x1 x2 axis at point 3 comma 3. So whatever the value we are writing here, if it is 1, then the corner will lie at 1 comma 1. If it is 3, then corner will lie at 3 comma 3. So I will draw the boundary that is satisfying this equation in x1 x2 plane. This corner point is 1 comma 1. So this inverted L shaped boundary here that I have drawn is the boundary which satisfies this maximum x1 comma x2 is equal to 1 equation. At anywhere on this boundary, you can check, you can take any point on this line, on these two lines, and check that here maximum x1 comma x2 will be equal to 1. Okay, and to the right of this line, this entire region, to the right of this line, this whole region of x1 x2 plane which is lying to the right of this green boundary is the region for which maximum x1 comma x2 is greater than 1, and the region that is lying to the left of this line that I have drawn here, the region that is lying to the left of this line, this entire region of x1 x2 plane is the region for which maximum x1 comma x2 is less than 1. So combining these two regions, we can see we need to combine this boundary, this inverted L-shaped boundary, plus the region that is lying to the left of it. So this probability here is nothing but the sum of all the joint probabilities which are lying in this region, that is combination of this inverted L-shaped boundary plus this region that is lying to the left of this one. So we can clearly see here that there are 4 points that are lying inside plus 2 points that are lying on the boundary. So summing up the joint probabilities of these 6 points, we get this probability. So the joint probabilities of these 6 points are these 6 probabilities. So adding these 6 probabilities, LCM is 72. This will be 35 by 72. So that is the answer to this probability. So now we will see how to solve the part B minimum function using the same approach here that we have used for maximum function. So let's see part B. So I have copied here all the data that is required for part B. In the part A, we used this conclusion that I have explained in question number 102, part A and part B videos. So the conclusion at the end of the video, I told that maximum x1 comma x2 is equal to small z is the inverted L-shaped boundary in x1 x2 plane with corner at z comma z. So we saw in part A that maximum x1 comma x2 is equal to 1 is the boundary, is the inverted L-shaped boundary in x1 x2 plane with corner at 1 comma 1. So we draw here line, this boundary here, inverted L-shaped boundary that we draw here with corner at 1 comma 1 is the maximum x1 comma x2 is equal to 1 line. Similarly, in part 3 and part 4 of question number 102, I explained that minimum x1 comma x2 is equal to z is the L-shaped boundary in x1 x2 plane with corner at z comma z. In part B, he has asked about the probability minimum x1 comma x2 is greater than equal to 1. So for this, we need to identify the region for which minimum x1 comma x2 is greater than equal to 1. For that, we need to first identify what is the boundary for which minimum x1 comma x2 is equal to 1. And from this conclusion, we know that it will be an L-shaped boundary in this x1 x2 plane. We need to draw an L-shaped boundary here whose corner will be at 1 comma 1. So I will now draw that boundary here. So this corner is 1 comma 1. So this is the L-shaped boundary for this equation. So on this entire boundary, minimum x1 comma x2 will be equal to 1. And the region that is lying to the right of this boundary, for this region, minimum x1 comma x2 is greater than 1. And the region that is lying to the left of this boundary, this whole region that is lying to the left of this boundary, for this region, minimum x1 comma x2 will be less than 1. For all the points that are lying in this region that is lying to the left of this boundary, minimum x1 comma x2 will be less than 1. So this inequality includes two regions. One is the boundary that on which this is equal to 1, and other is the region for which it is greater than 1. So this boundary plus the region that is lying to the right of this boundary. So we can observe here that there is only one point that is lying on this minimum x1 is equal to x2 is equal to 1 line, and there is one point that is lying in this minimum x1 comma x2 greater than 1 region. So in total there are 2 points that are lying in the region that is specified by this inequality, minimum x1 comma x2 greater than equal to 1. So we will add up the joint probabilities of these 2 points, and that will give us the probability minimum x1 comma x2 is greater than equal to 1. So we can see for these 2 points the probabilities are these 2 probabilities. So the answer will be 1 by 18 plus 1 by 18. So it will be 2 by 18, which will be 1 by 9. So that is the answer to this problem. So I hope you have enjoyed the solution of this problem. This is the graphical method of solving the problem, and it is more interesting than the conventional method of solving these minimum maximum functions. So I will be bringing more such interesting methods. So for that, please do subscribe to my channel and press the like button below this video also. So thank you for watching this video.